Let's begin with bulk lithography. It is the one of the bulk micro machining process. So both are the same, bulk lithography or bulk micro machining process, because both are working on a same platform and which will use mostly for 3D micro fabrication process. So in this we are going to discuss about the process and other parameters, that is applications and 3D micro fabrication process, how it is carried out, uh, and some of the example how actually bulk lithography works. So those things we are going to learn in this module. So let's begin. The applications are pressure sensor membranes, those are micro membranes, and the grooves and micro channels which are visible, and micro cantilever chemical array. So that cantilever array is shown in this figure. So these are the different applications of our bulk lithography. Bulk micromachining. Bulk micromachining is the process that defines the structure by selectively removing or etching into a substrate. This is a subtractive process. Examples are carved faces into Mount Rushmore, and that is below left, and cliff dwellings that constructed below right into the side of the mountain used in a bulk each process. So these are the two different applications where the bulk micromachine is used. Bulk micromachining is the entire thickness of the silicon wafer or SiO2 or a substrate which is used to form microsystem structure, which remove relatively large amount of silicon substrate and construct high aspect ratio structures such as fluidic channels and chambers, which is shown in the figure. So these are the different channels where you observe that these are the different channels where you observe the chamber and alignment of a groove are there. Monocrystalline silicon wafers are selectively etched to form a 3D MEMS devices and construct the sensors including micro-pressure sensors, cantilever arrays, and accelerometers. So microfluidic channels with high aspect ratio fluidic chambers of SEM is shown in this figure. Then bulk microportioning process, the process which is used to fabricate MEMS pressure sensor. A thin film of a silicon nitride is deposited on the both sides of front side and back side of the wafer, and the back side of the nitride film is patterned and plasma etched, creating the openings for the chamber. And the silicon nitride is used as a hard mask, and the surface micromachining process, that is deposition, pattern, and etch, are used to create an electronic sensing circuit by depositing chrome, then gold thin films on the top of silicon nitride. Anisotropically etch the backside chambers using a KOH solution for the bulk etch process. The backside silicon nitride acts as a pattern mask while the front side silicon nitride is the etch top. The front side silicon nitride directly over the backside chamber operates on the pressure sensor diaphragm because it can now deflect up or down with changes in the pressure, that is shown in this figure. So this is the back end side of the, okay, left one is front side and right one is back side. Okay. So if you observe that MEMS pressure center front side, that is left, showing the electronic sensing circuit each in a gold film layer. So it is each in a gold film layer. While this is the back side, that is right, that is showing in the chamber. Okay. So how the electronic system is shown, that is sensor pressure sensor is mentioned in this format. Bulk micromachining components are cantilever array, nozzles, microfluidic channels, needle arrays, then AFM probes, membranes, chambers. two wafer connections. There are some of the three-axis monolithic accelerometers. So all these comes under the micro channels and micro fluidic channels, and some of the micro grooves are available. Those are done for different type of machining or MEMS objects or sensors like accelerometer. Where this is a cantilever array. So micro level the arrays which are formed that is shown in this SEM graph. 3D microfabrication process is we already studied in photolithography. The same process is there. Here it is a first vapor cleaning is there, then deposition. Before going to deposition, there is a evaporation. That means in a vacuum chamber, we have to evaporate the vapor surface. Water droplets not be there. Then sputtering, that means whenever it's electric components are there, that time atom transfer will be considered or molecule transfer will be considered in a sputtering. Then CVD, that is chemical vapor deposition process, is also applied on with the help of metals, while resist processing and the pattern. So, as like a photolithography, we are using that resist processing and pattern, where the first we have to do thin film deposition, then coating of resist, then UV exposure and removal of unwanted material. Okay, that is for pattern transfer. While lift-off condition is there, that time we are coating of a resist, UV exposure and development, then metallic deposition and removal of resist and unwanted metal. So the lift-off process where the photoresist pattern is generated initially on the substrate, and instead of etching the unwanted material is there. Okay, so that is considered in a resist processing pattern. So, if you observe that bulk, dry or wet etching of relatively large amount of silicon substance are used, and etching will be done on structural layers and sacrificial layers. Okay, so there is having isotropic, anisotropic, and thin film substrates are there. Where isotropic substrates it means whatever the photo masking is done or whatever the light beam or beam will be at, that will be solidify that particular part. Okay, but in aniso that will solidify while doing the solidification it create a cantilever part. Okay, while in case of anisotropic, it will not create that cantilever part, it will directly dissolve into the solution. Okay, so if it is not properly etched, then we have to repeat the step for the deposition for new layer and wafer level bonding and packaging. So we have to repeat the stage. So this deposition, resist process and pattern and etching is the one of the basic area of 3D microfabrication process, and the wafer level and bonding packaging. So after one layer there will be another layer which is created. That is a layer by layer process. As we know, it is a 3D printing. So processing of a bonded wafer will be again come to the deposition. Then there will be a dicing that is shown in the figure. Then there will be a die attach. So that is the attachment and release attach release each. That means required only for a devices with surface micro machine parts. So there is a one of the etching parts are there or silicon substrate is mounted on that, and that etching will be released, and then final packaging and testing. Microsystems may require non-electrical interfaces that is shown in this figure. Okay. So bulk micro machining of for cantilever, where top side of substrate that is oxidized silicon vapor is there, SiO2 that is shown in the figure. Then the photolithography to define the cantilever dimension and oxidize the etching, and photoresist will create like the part and oxide etched by BHF. Okay, so after that, it's having create a cantilever structure. That is, this part is only there and this part is easy to remove. And after getting this removed part, we get a cantilever structure. Thank you so much